Remark comes with a command line interface, or CLI, that can be used to automate tasks. First, just go ahead and inspect a document. The inspect option logs out the entire AST, which can be used for debugging plugins. As we also see here, we have a table of contents heading and no children beneath it. We can automatically populate this by using the remark talk plugin as part of the CLI command. Now the table of contents has been populated. However, if we run the inspect command one more time, we'll see that the table of contents has not been persisted. That's because we didn't specify the output. With the output option specified, we can now inspect one more time and see that it has been populated. In addition to plugins that manipulate your markdown, you can also use plugins for linting. Here, we'll lint against a markdown style guide. When you run the command, we'll see a list of errors that have been generated based off our preferences. We can additionally run commands based off whether the linting passed or failed. Though for this to work, we'll have to specify the fail option, which means it will error out. This results in us seeing fail rather than pass. In order to generate a dynamic table of contents in our markdown document, we'll need to install the remark talk library. When that's complete, we can begin editing our build script. As you can see, we're currently invoking remark and passing it the remark HTML plugin. We'll also need to require the remark talk plugin and pass it to remark as well. Remark talk uses a special heading in your document in order to know where to place the table of contents. We'll go ahead and add that. Now we can rerun our build with yarn start and refresh the HTML page. Our table of contents has been added and is generated based off the headings in our document. However, the links do not work. If we inspect the table of contents links, we see that there's a slugified ID that we're linking to. However, those IDs are not being added to the headings. In order to slugify our headings, we can use the remark slug plugin. After we yarn install the library, we can require it and then pass it to remark as well. After we run our build with yarn start, we'll see that the H2 now has a slugified ID. This ensures that our table of contents links now work. Altogether, we use the remark talk library to generate a dynamic table of contents based on headers. Then we use remark slug to slugify the headings. This results in a fully functional, linkable table of contents. In order to convert markdown to HTML, we'll need to install remark and the remark HTML plugin. We'll also need to create our markdown document and touch the build script, which we'll use to run the plugin. We'll also need to add the build script to our package.json. Now we can begin working on our build script. First, we'll require the fs module and read in our document with read file sync. This will read in the markdown document as a string. We'll also need to require remark and remark HTML. Now we can invoke remark and pass it the remark HTML plugin. Then we can call process sync and pass it our document. The result will contain a contents key that has our raw HTML. However, we'll need to wrap it in an HTML tag. Now that we have a valid HTML string, we'll need to write it to disk so we can read it with our browser. We can now run yarn start, which runs our build, and open up the index.html file with our browser. We've successfully converted our markdown to HTML. Let's inspect it. Looks good to me. Altogether, we've used the fs module and then read file sync to read in our document as a markdown string. Then we've used remark and the remark HTML plugin to convert a markdown document to HTML. We wrapped it in an HTML tag using a template string and then wrote it to disk, which we opened in our browser as index.html. In order to create a remark plugin, we'll need to initialize a project. Then we'll need to install the development dependencies. We'll install remark so we can run the plugin and jest to run our test script. Then we'll need to add our test script. And now we'll create our fixture markdown file that we can use in our test. Now we can begin our test.js file that jest will run. First, we'll need to require fs and read in our fixture document. Then we can scaffold out our test. For this test, we'll be adding breaking in front of all h1s, so we can go ahead and assert. We also need to require remark so we can pass it our document. First, we'll invoke remark and then call process sync with our doc. Remark returns a virtual file and a contents string, so we'll need to reference contents in our test. Now we should be able to run our tests and see it fail. As we can see, the breaking is not added because we haven't written our plugin yet. It's time to begin working on our plugin. All remark plugins first receive an options object and then the AST structure, or the tree. We'll go ahead and log that for now. We'll also need to modify our test.js file so we actually use the plugin. So we can require it, and then call use and pass it to plugin function. We're now ready to run our tests. As we see, we've logged out the AST structure. There's a root, that's the main part of the document, heading 1 of depth 1, which means our H1, our paragraph, our heading 2, and of course the last paragraph. We'll now install unist util visit so that we can walk our tree structure and only find heading nodes. First, we'll require the library, and then we'll call the visit function and pass it our tree, then specify the heading node, and then give it a callback which will receive the node. For now, we can go ahead and just log it. Let's run our test to verify that the headings are being logged. As you can see, here's our heading 1 and our heading 2. Looks good. For this plugin, we only care about headings of depth 1, so we'll need to restrict our visitor. We can do this by short-circuiting if the depth is not 1. Now we can run our tests again. We'll see that there's a single heading node of depth 1, and also that there's a children's child array of text values. We'll need to use unist util visit on the heading node as well to visit the text values. We can do this by calling visit again with our heading node and specify the text node type. It'll give us a new node which we can go ahead and log. Running yarn test again results in a single text node that's a child of our heading node. We're now ready to modify the value in the text node by prefixing it with breaking. Running our test one more time will result in a passing test. The breaking is being prefixed to our heading 1. Let's edit our test file to log out the entire document after our plugin to make sure everything looks right. And here's our document. It looks good. Altogether, we've written a plugin that takes the AST and then uses unist util visit to find all heading nodes and narrow them down to those of depth 1. Then we traverse the heading node one level deeper to find the text node, which is what we then prefix with breaking. In our test, we require our plugin and pass it to remark calling .use, followed by process sync with our document. Lastly, we assert that our H1 has been prefixed with breaking. Install unist util remove. Then we can require it, and then call the remove function by passing it the tree and the node type that we'd like to remove. As we can see now, all images have been removed from our document. In some cases, you might only want to remove nodes based off their parent context. So for this example, we will only delete images that are contained within a heading. To achieve this, we can combine unist util remove with unist util visit. We can require the unist util visit library and visit all heading nodes in our tree before calling the remove function on all heading nodes. Now we'll see that only the image contained within our heading has been removed. First, we're going to begin with our tests. We'll also want to open up the fixture file so we can look at what headings that we'll expect in our result. Remark will return a data object as part of the result. We can destructure the headings from there, which we can then assert against in our test. With a test written, we can run yarn tests and make sure that it fails. Now we can begin implementing our plugin. In addition to our tree, we're also passed a virtual file from Remark. This is what we were taking the headings from, so we can also use that in our plugin. To start, we'll add some mock data. We can run our test again to make sure our mock data is being returned. Now it's time to actually visit our heading node, so we can yarn add unist util visit. We can then require the library and then use that by passing it the tree and selecting all heading nodes. To start, we can take the depth from each heading node. On the file object, we'll need to set the default for headings in the data, and then push the depth as a key in the object. We can run our test again and see the proper depth being added to our data attribute. From within our heading node, we'll also need to visit the text nodes. We'll also instantiate a text string, which we'll add to for each of the text nodes that we visit. Lastly, we can add the text to our returned object. We can run our test one more time and we should see that it passes. We've stored all headings as a data attribute on our virtual file. Altogether, we've required unist util visit, added a default headings value, visited every heading node, recorded the depth, aggregated the text, and then pushed that to our file. In our test, we retrieved the headings data from our virtual file and then asserted against the headings that we expected.